All right. Good morning, good afternoon, good evening, or depending on your time and your location. If you are considering installing a generator as a reliable source of power for your industries, residentials, one that will operate efficiently and deliver maximum performance, then you are at the right place. In this video, I will guide you through the essential steps required to achieve a safe, effective, and long-lasting installation. For us to achieve this, you have to first turn on all your electrical appliances and using a clamp meter of 600 amp to measure the current. Now, let's take this scenario. Assuming your clamp meter gave you a reading of each of these three phases to be 10 amps, then you have to substitute it into the formula which is shown above. Power equals to current times voltage multiplied by root of 3 times the power factor. On substituting this, knowing fully well that our voltage is 400 volts, we substitute the aforementioned, it is going to give us what? 5.5 kilowatts after multiplication, as you can rightly see. Then, there is a need for us to understand how generator actually work. Generator is an electrical power unit with a rated apparent power output, which can be 50 kVA, 100 kVA, respectively. But the rating defines the maximum electrical load generator can supply and the standard that is considered. And now, for us to do this, the kVA measures generator's capacity, which include the real power, which is in kilowatts, which is the usable power, and the reactive power, which is in kVAR, which is the magnetizing power. Now, in selecting a right generator to size for this load residential, as we like to say, we have to first convert the kilowatts, which is the residential load that we have measured, to kVA. By so doing, we are going to substitute it into the aforementioned formula, as you can see above. kVA equals to kilowatts divided by the power factor. Now, assuming that in our residential, our power factor is 0.8, then therefore our kVA is equal to 5.5 kilowatts divided by 0.8, which is going to give us 6.875 kVA. And approximately the minimum generator size to install in that residential is 7 kVA generator. However, a good practice is to either increase it to 20 to 30% for the aforementioned reason, or for the reason below, stating the starting current of either your fridge or your AC or even your pump if you are using any. Because of that starting current, we have to increase it by 20 or 30%. Another reason of increasing it by 20 to 30% is for future expansion. Probably you want to add other loads to your home appliances. Then the third reason is for the long generator life. Now, having done this, we have assumed that we have the minimum generator to be used to be 7 kVA. Now, because of the aforementioned reason, we are going to multiply 7 kVA times 1.3, which is going to give us 9 kVA. And for us to move further, for this installation to be effective and the generator to be protected, then we need a protective device. a rated protective device according to standard. And for us to achieve this using the apparent generator reading and voltage, then continuously we know that the generator is going to be a continuous load running. And the standard is that we have to calculate the current. By calculating the current, we are going to use the formula, which is current equals to kVA times 1000 divided by the root of 3 times voltage. Now, if you substitute our generator rating from the previous generator rating we got from the residential, which is 9 kVA, divide by the root of 3, multiply by voltage, which is 400 amps, as you can see above, which is going to give us what? 12.09 amp. Remember that a 3-pole MCB in manufacturing is 16 to 20 amps. So your rated MCB of 3 poles should be within the range of 16 to 20 amps. Now, I want you to understand that in a successful installation, there must be a cable route. The use of proper cable management is also essential for a reliable and efficient work. So for 20 to 25 amp MCB, you use 400 mm cable. But this is conditional because it's depending on the length of which the connection is going to be placed to avoid a voltage drop. I want you to share this video so that others can as well gain knowledge. Thank you.